Bat 9998 is a Wolf-Rayet star located near the R136 cluster in the Large Magellanic Cloud, and it's no ordinary star. Bat is one of the most massive stars known, with an estimated initial mass of 250 solar masses. Initially identified in 1978 by George Melnick and simply known as Star J, it is now thought that the star is the most massive and most luminous star known. Hi everyone, Vega here, and in today's video we return to our brightest star series to focus on a star whose extreme properties are quite simply mind-blowing. So let's get to it. First things first, some of you folks may have been watching the channel for over a year now and will remember a video on the star of Westerhout 49II. When we look through the list of most massive stars, we see Bat 9998 and R136A1, another possibly more famous star, but the name of Westerhout 49II seems conspicuous in its absence. Indeed, we have to drop considerably down the list until we actually find the star. This is because there is a significant uncertainty about Westerhout 49II's properties. One estimate using the mass-luminosity relations finds a mass between 90 and 240 solar masses, although its mass is likely higher than the theoretical upper limit of 150 solar masses, which means it could even be a binary if X-rays are detected. Sister stars like Westerhout 49I and 4912 are all bright X-ray sources, which means that they could also be binary stars, and their masses would be lower than the predicted mass if they were single stars. So in essence, our previous king, Westerhout 49II, is a troubled old fellow, and many folks don't really understand him, and so he's been replaced with a new king, and that king is Bat 9998. Let's get one thing straight off the bat, pun intended. Bat 9998 is massive, but not necessarily large. Supergiants like Rigel 79 solar radii or Stephenson 218 with 2150 solar radii are more voluminous stars. They're not as powerful. Bat 9998 has an estimated luminosity of 5,012,000 suns and is a Wolf-Rayet star. Wolf-Rayet stars are rare massive stars with unusual spectra, and they exhibit strong stellar winds and temperatures hotter than almost all other types of stars. Their luminosity, like with Bat 9998, can reach millions of times that of the Sun, but interestingly, much of their radiation output is actually in the ultraviolet. In this diagram we see some facts about Bat 9998 compared to previous record holders of R136A1 and Westerhout 49II. We must bear in mind that the figures are subject to current research and remain under review and subject to constant revision of their masses and other characteristics. We can see the upper end of the estimates that theoretically Westerhout 49II does remain the largest theoretical star we know of, and indeed R136A1 would also, at its upper limit, usurp Bat 9998 in terms of mass, but the extra heat of Bat 9998 does contribute to a high luminosity. I suppose what we can say is there's a bit of a Game of Thrones scenario going on at the top, with each contender, Bat 9998, Westerhout 49II and R136A1 vying for the rule. But for now, Bat 9998 is sitting on the Iron Throne. Of course, apologies to those who haven't actually seen the Game of Thrones series, but you get the picture. So perhaps the best way to understand the sheer power of this star, which incidentally shares the Tarantula Nebula with R136A1 and other significantly massive stars, and as stargazers we must really top our hat to that small southeastern corner of the Large Magellanic Cloud. Quite incredible just how many gigantic stars are in it, as we see here in the list. Indeed, it might interest some of you to know that the famous supernova 1987A occurred in the outskirts of this Tarantula Nebula, another huge star going boom this time. South of the 20th parallel south, the Large Magellanic Cloud is circumpolar, meaning that it can be seen, at least in part, all night every night of the year, weather and light pollution permitting. In the northern hemisphere, it can be seen visible south of the 20th parallel north, and this excludes North America except southern Mexico, Europe, northern Africa and northern Asia, so yet again, another win for our friends in the southern hemisphere. In the night sky though, Bat does appear as a 13th magnitude object, so it's not something we can see without a substantial telescope. Based on my own somewhat rudimentary calculations, a theoretical habitable zone for such a star would begin at around 0.03 light years, or some 283 billion kilometers, and end at around slightly over 0.1 light years, or around 1 trillion kilometers. It's absolutely astonishing to think about, but in reality such a star would have seemingly zero possibilities of harbouring life. based on its extremely short lifespan, estimated at around 5 to 10 million years. In today's final graphic, for fun, we can imagine what the Bat star would be like if it were to appear at 11.4 light years distance and replace the current star that sits there of Procyon, Alpha Canis Minoris. At this distance, the star of Bat begins to replace Procyon and swells to a maximum brightness of -14.327, or around 4.5 times brighter than the full moon and enough to read a book by. It's incredible, isn't it? 11.4 light years away, but already 4.5 times brighter than the full moon. Bat 9998 is a supermassive Wolf-Rayet star located in the Tarantula Nebula of the Large Magellanic Cloud. It's unclear whether it is the most massive and luminous star known, as much depends on accurate distance measurements, but current understanding is that it is. A southern hemisphere star with a potential habitable zone, it would reach out as far as 1 trillion kilometers, or 1/10 of a light year, and the star is so powerful if it were to replace the star of Procyon, it would become the second most luminous object in our skies and shine all day and night. As calculations improve, one day perhaps we'll know for certain which of a group of these huge blue stars is the true king, but for now the crown is owned by the Bat 9998 star. Thanks for watching and consider subscribing if you haven't already. If you'd like to support the channel further, you could consider joining the channel, which comes with some membership perks, or alternatively buy me a coffee, and I'll link this in the description. Many thanks to those of you who have already done so, and if you have any video subjects you'd like to see brought to life, let me know in the comments below. Take really good care of yourselves and look after your friends and family well, and I'll see you on the next one.